Assalamu alaikum. Today we're going to further integrate the trigonometric functions. This is part 2 of the previous class where we are integrating the trigonometric functions using the double angle formula. Okay. The first question here, show that if y equals to sec of x, then dy by dx equals to tan x sec x. Okay, sec x can be also written as 1 upon cos x. If I apply the formula, the quotient rule for differentiation, that means u upon v. If y equals to u upon v, then dy by dx equals to v u dash minus u v dash upon v square. Okay, in this question, u is 1 and v is cos of x. Okay, so let's start with this. U is 1, u dash is going to be 0, v is cos x. So v dash is going to be, differentiation of cos x is minus sin x. Okay, let's differentiate it. Dy by dx is v, which is cos x, minus u dash, v u dash, differentiation of 1 is 0, minus u v dash is minus sin x upon v square, which is v is minus sin x, sorry, v is cos x, and you have to just do cos square x here. Okay, this is going to become as 0. Now this is sin x upon cos square x. Let's write it down. Sin x, positive sin x upon cos square x. If I separate sin x in the numerator with 2 cos x in the denominator, 1 sin x upon cos x will become tan x, and 1 upon cos x will become sec x. So this is equivalent to tan x sec x. Proved. We have proved that dy by dx is going to be tan x sec x. Now hence find the exact value of cos of 2x plus 5 tan x sec x. Okay, so you have to integrate cos of 2x for the b part. Cos of 2x plus 5 tan x sec x dot dx. Okay, we know cos of 2x integration is going to be sine of 2x divided by 2, and 5 times tan x sec x. If the differentiation of sec x is tan x and sec x, that means the integration of tan x and sec x is going to be sec x. Okay, so in place of tan x and sec x, I know the integration of this is going to be sec x. So I'm writing sec x here. We have integrated it. Now putting the boundaries, which is pi by 4 and 0. Okay, so it will become sine of 2 by pi by 4 upon 2 plus 5 of sec of pi by 4, the first bracket, minus sine of 0, if you plug in here, it will become 0 only, 5 sec of 0 plus 5 minus 5 sec of 0. Okay, let's solve this. 2 1 times, 2 2 times. This is pi by sine of pi by 2. Sine of pi by 2 we know is a 1. So it's 1 upon 2 plus 5 sec of pi by 4. Cos of 45 degrees we know is root 2 upon 2. Okay, cos of pi by 4 is root 2 upon 2. So sec of pi by 4 is going to be 2 upon root 2. Okay, so I'm writing it here. 5 root 2 upon root 2. Okay, minus 5 sec of 0. Sec of cos of 0 is 1, so sec of 0 is going to be 1 only. Okay, so minus 5 here. So 5, half minus 5 is going to be minus 9 upon 2 plus 10 upon root 2. Okay, 10 root 2, you multiply by root 2 upon root 2, you will be getting 10 root 2 upon 2, which is equals to 5 root 2. Okay, so in place of 10 root 2, I'm going to write minus 9 upon 2 plus 5 root 2. This is the final answer to this question. Okay, moving on to the next one. Prove that cosec 2x tan x equals to sec square x. Okay, so it's using the identity, you have to prove it. Okay, first of all, we know sine of 2x equals to 2 sin x cos x. Okay, cosec of 2x will be the reciprocal of this, which is 1 upon 2 sin x cos x. Okay, let me write in place of cosec 2x, I am writing 1 upon 2 sin x cos x multiplied by tan x. Tan x is sin x upon cos x. Okay, sin x and sin x will cancel out. You are 2 and 2 will cancel out. You are left with 1 upon cos square x, which is actually sec square x. So this is proved. Hence, find the exact value of 5 plus cosec 10x tan x. Cosec 2x tan x. Now, in place of cosec 2x tan x, we can put half of sec square x. If you make this the subject, cosec 2x tan x is, this 2 is going to go down in the denominator. Cosec 2x tan x is going to be 1 upon 2 sec square x. Okay, so we have to integrate 5 plus 1 upon 2 sec square x dot dx, and the boundaries are pi by 3 and negative pi by 3. Okay, when we integrate this, integration of 5 is going to be 5x, integration of sec square is going to be tan x, okay, so putting the boundaries of pi by 3 and negative pi by 3. Okay, 5 into pi by 3 plus half tan of pi by 3, this is the first bracket, minus 5 into negative pi by 3 plus half into tan of negative pi by 3. Okay, let's simplify this. This will become 5 pi by 3 plus half. Tan of pi by 3 is root 3 minus 5 pi by 3 minus half. Tan of negative pi by 3 is going to be negative root 3 upon root 3, negative root 3. Okay, let's simplify this. 5 pi by 3 plus 5 pi by 3 will become 2 times 5 pi by 3. Okay, root 3 upon 2, negative, this has become positive. Root 2 upon 3 upon 2 and minus negative root 3 upon 2 will cancel out then, obviously. This will cancel out. You're left with 10 upon 3 pi as the final answer. Okay, there's a minor mistake here. So if I just write 2, this was a positive. Okay, so this will become positive. So the only thing is that root 3 upon 2 plus root 3 upon 2 is going to become 2 root 3 upon 2. So the final answer is this now. 10 upon 3 pi plus root 3. Okay, moving on to this question. By differentiating cos x upon sin x, show that y equals to, if y is cot x, then dy by dx equals to this. Okay. Okay. This is equals to cot x. So if y is cot x, you have to differentiate this. Okay. If I take u as cos x, obviously I have to apply quotient law. So u dash is going to be differentiation of cos x is minus sin x. If v is sin x, differentiation of sin x is cos x. Okay, let's apply the formula. Dy by dx equals to v, which is sin x, u dash, which is minus sin x, minus u, which is cos x, differentiation of sin x is cos x, upon v square. This will become minus sine square x minus cos square x upon sine square x. If I take out minus as common, I'll be left with sine square x plus cos square x inside the bracket upon sine square x. This is minus 1 upon sine square x, which is actually minus cosec square x. Proved. So we've proved the first part. Now they are saying hence show that the integration of cos square 2x is equals to this when you apply these boundaries. Okay. Now we know that if y is this, dy by dx is this. Okay. So if I just write it down, integration of negative cosec square x dot dx is equals to cot x. Now what do we have to integrate is cos square 2x. So if I first shift this negative outside, okay, cosec square x dot, okay, so negative cosec square x dot dx equals to cot x. Okay, negative I can shift to that side, cosec square x dot dx equals to negative cot x. Now if I'm multiplying the angle here by 2, so cosec square 2x dot dx is going to be negative cot of 2x. Okay, so I have to apply the boundaries now on this, which is pi by 4 and pi by 6. Okay, so minus I'm keeping it outside, or I can take a minus inside, there's no problem with that. I can write minus cot of 2 pi by 4. Okay, then a minus sign, and then minus cot of 2 pi by 6. Okay, let's solve this. Okay, when I simplify, I'm getting a pi by 2 here. Cot of pi by 2. Tan of pi by 2 is undefined. So it's going to be, okay, we know tan of pi by 2 is equals to undefined. Okay, so cot of pi by 2 is going to be the reciprocal of this 1 upon undefined, which is actually a 0. So this will be a 0. Minus, or you can write plus, cot of pi by 3. We know tan of pi by 3 is 1 upon root 3. Sorry, tan of pi by 3 is root 3. So cot of pi by 3 is going to be 1 upon root 3 plus 1 upon root 3. Okay. Okay, you had to prove that it's equals to, just check, root 3 upon 6. Okay, just hold on. 1 upon root 3, if I simplify, it's 1 upon root 3 multiplied by root 3 upon root 3, which is root 3 upon 3. Okay, so there is a minor problem. Let us sort it out first. Okay. Let me just apply the boundaries once again. Okay. From here I'm going to start with it. Once again, applying the boundaries. Okay. If I if I keep minus outside, cot of 2x, I have to apply the boundaries of pi by 4 and pi by 6 on cot of 2x. Okay. Fine. Minus outside, cot of 2 pi by 4 minus cot of 2 pi by 6 minus, it's cot of pi by 2, which is the reciprocal of tan of pi by 2. So tan of pi by 2 is actually undefined, we know. Tan of 90 is undefined. Okay, so it's undefined. So cot of pi by 2 is equals to 1 upon undefined. Okay, 1 upon 0 is undefined. So 1 upon undefined, if you make undefined, 0 goes there. 0 equals to 1 upon undefined. So 1 upon undefined is going to give you a 0. So this is 0 minus cot of pi by 3. Cot of pi by 3 is the reciprocal of tan of pi by 3. Tan of pi by 3 is root 3. Tan of pi by 3 is root 3. It's going to be 1 upon root 3. Okay. So this becomes plus 1 upon root 3. If I simplify this, I'm getting a root 3 upon 3. Okay. The only mistake which I have made here, which I have understood here, just hold on, let me correct it very quickly. Okay, we had reached this point. Okay, integration of cos square x should be minus cot x. Now I had to integrate cosec square 2x dot dx. Okay, as per the question the requirement of the question. This will become integration of cot of 2x divided by 2. Okay, so that's how, because whenever you integrate something, it's if it's a 2, then you have to divide it by 2 as well. So you have to apply the boundaries on minus half. I'm keeping it outside. Cot of 2x, I have to apply the boundaries of pi by 4 and pi by 6 onto this. Okay, let's do it. Pi by 6, pi by 4 and pi by 6. Minus half, I'm keeping it as it is. Cot of 2 pi by 4 minus cot of 2 pi by 6. Okay, minus half. This we decided was tan of the reciprocal of tan of pi by 2. Tan of pi by 2 is undefined, so 1 upon undefined, which is a 0, minus cot of pi by 3. Tan of pi by 3 we know is root 3, so it will be 1 upon root 3. So it's going to be plus 1 upon 2 root 3. Okay, if I rationalize this, I'm getting a root 3 upon 6 as the final answer, which is correct now. Okay, so it was a minor mistake, which I've corrected. Okay, coming on to question number 5 right now. कौन है? Question number 5. Show that tan of x plus cot of x is equals to 2 sine 2x. Okay. This we have to prove, so let's do this first. Okay, tan of x plus cot of x. Tan of x is sine of x upon cos of x, and cos of x is cot of x is cos x upon sine x. Let's simplify this. I'm taking out the LCM, which is sine x cos x. This will become sine square x plus cos square x. Okay, this is equals to obviously 1 sine square x plus cos square x upon sine x cos x. So 1 upon sine x is cosec x, and 1 upon cos x is sec x. This is what we had to prove in the first part. This is equals to, okay, fine. Okay, instead of changing into this, I know the double angle identity for sine of 2x is 2 sine x cos x. Okay, so if I just want sine x cos x the subject, if I want to keep sine x cos x the subject, it will become 1 upon 2 sine of 2x. Okay, so 1 divided by sine x cos x. So it's 1 upon 1 multiplied by 1 upon sine x cos x, and we know sine x cos x is equals to okay, what I can actually do is, in place of sine x cos x, I'm writing half sine of 2x. Half sine of 2x. Okay, 1 divided by half is 1 multiplied by 2 upon 1. So it's 2 upon sine of 2x, which is equals to 1 upon sine is cosec. So it'll be 2 cosec 2x. This is what we had to prove. Okay, we just had to keep it like this. So this is the answer. This is what we had to prove here. Okay, moving on to the second part of the question. Hence show that hence show that 8 upon cot of x plus cot of x is equals to this. Okay, 8 upon cot x plus tan x plus cot x. In place of tan x plus cot x, we can write 2 upon sine of 2x. Okay, so I'm just copying it again so that I don't have to scroll up again and again. Okay, so it's 8 divided by, in place of tan x cot x, I'm writing 2 upon 2 divided by sine of 2x. Okay, so 8 divided by 2 upon sine of 2x, it will become 8 multiplied by sine of 2x divided by 2, 4 sine of 2x only. Okay, so it is equals to this. You have to prove that 8 upon this equals to 1 when you put the identity. So I have to integrate this. So that means this according to me is equivalent to this. So I have to integrate this, putting the boundaries of pi by 2 and pi by 3. Okay, so if I integrate 4 sine 2x, I will get 4 negative 4 cos of sine. Integration of sine is negative cos, that's why. Minus 4 cos 2x upon 2. Okay, and applying the boundaries of pi by 2 and pi by 3. If I simplify, I get minus 2 cos 2x. Minus 2, I'm putting it outside. I'm putting the boundaries on pi by 2 and pi by 3 on cos of 2x. Minus 2 cos of 2 pi by 2 minus cos of 2 pi by 3. Okay. This will become minus 2. Cos of pi is negative 1 minus cos of 2 pi by 3. Okay, cos of pi by 3 is root 3. Root 3 into 2. So 2 root 3. And this is lying in the second quadrant where cos is negative, so it will be positive then. Okay, so it's minus 2 into minus 1 is positive 2, minus 4 root 3. Okay, just hold on for a while. Okay, cos 2 pi by 3, I'm just checking it with the calculator. Okay, I made a mistake with this. This is not root 2 root 3. Okay, I was thinking in my mind, I was calculating tan of pi by 3. Okay, so it's going to be minus half. Minus cos of 2 pi 3 is minus half. So let's simplify this further. Negative 2 outside, minus 1 plus half, which is actually minus half, which is actually 1. Okay, so this is done. Moving on to the next question, which is this one. Okay, use the expansion of sine of 5x plus 2x and sine of 5x minus 2x to show that sine of 7x plus sine of 3x is equal to this. Okay, let's expand this first. Okay, sine of 7x equals to sine of 5x plus 2x. We are applying the compound angular identities here. This will become sine of 5x cos of 5x, cos of 2x plus cos of 5x sine of 2x. Okay, and sine of 3x equals to sine of 5x minus 2x, which is equals to sine of 5x cos of 2x minus sine of 2x cos of 5x. Sorry, I made a mistake here. Sine of 5x cos of 2x minus cos of 2x sine of 5x. Cos of 5x sine of 2x. Okay, so if we have to add them up, so I'm adding them up. Sine of 7x plus 3x equals to sine of 5x cos of 2x plus cos of 5x sine of 2x, this is the first bracket, plus sine of 5x cos of 2x minus cos of 5x sine of 2x. Okay, when you open the bracket, you will get 2 sine 5x cos 2x, and this will cancel out, obviously. Okay, this is what we had to prove. Hence, show that 2 sine fx cos 2x is equal to this. Now we know that this is actually the result of this thing. Okay, so I can write integration of 2 sine 5x cos of 2x dot dx is equals to integration of sine of 7x plus sine of 3x dot dx. Okay, so if I integrate this, sine of 7x will be minus cos of 7x divided by 7 plus sine of 3x would be negative cos of 3x divided by 3. I have to put the boundaries of pi by 3 and pi by 6 on it. Pi by 3 and pi by 6 on it. Okay, so minus cos. If I take out negative is common, believe me, that will be simpler. So if I take out negative is common, I'll be left with cos of 7x upon 7 plus cos of 3x upon 3 with the boundaries pi by 3 and pi by 6 equals to minus cos of 7 pi by 3 upon 7 plus cos of 3 pi by 3 upon 3 minus cos of 7 pi by 6 upon 7 plus cos of 3 pi by 6 upon 3. Okay, let's simplify. Okay, this minus is outside. Now cos of 7 pi by 3 upon 7. Okay, let me just do it with the calculator now. It's 1 upon 14 plus this and this will cancel out. Cos of pi we know is a 0. Negative 1, sorry. Negative 1 upon 3 minus cos of 7 pi by 6. That's what I'm calculating with the calculator. 7 pi by 6 negative root 3 upon 2 divided by 7 is negative root 3 upon 14, negative root 3 upon 14 plus cos of pi by 2 is 90. Cos of pi by 2, cos of 90 is a 0. 0 upon 3 is going to give you a 0 only. Okay, let's simplify this. Minus outside. 1 upon 14 minus 1 upon 3 plus root 3 upon 14. Okay, minus 1 upon 14 plus 1 upon 3 minus root 3 upon 14. Let's see how they have written the answer. Okay, they've taken out the LCM, so I'm also doing the same. 42, 14 3 times, so minus 3 plus 3 14 times plus 14 minus 14 3 times, so 3 root 3. This is 14 minus 3 is 11 minus 3 root 3 upon 42, which is the final answer. Let's check what have they given. 11 minus 3. Okay, fine, that's correct. Okay, so we have to do 2 more questions now. Question number 7 and question number 8. And maybe 10 as well, depending on the time. Okay, this one. Sine of, show that sine of 3x is equals to 3 sine x minus 4 sine cube x. Okay. So, if I write sine of 3x as sine of 2x plus x, okay. So I can write sine double angle identity. If I use sine of 2x cos of x plus cos of 2x sine of x. Okay, sine of 2x is equal to 2 sine x cos x into cos of x. Okay, plus cos of 2x is equals to, if I use the double angle identity, it is 1 minus 2 sine square x into sine x. Okay, so if I multiply this, I will get 2 sine x cos square x plus sine x minus 2 sine cube x. Okay, if I change cos square x to sine square x, it will become 2 sine x into 1 minus sine square x. Okay, just writing down the basic identity of sine square x and cos square x. Cos square x equals to 1 minus sine square x. Okay, I'm doing it correctly. Plus sine x minus 2 sine cube x. This will become 2 sine x minus 2 sine cube x plus sine x minus 2 sine cube x. This has become 3 sine x minus 4 sine cube x. Okay, so this is what we had to prove in the first part. The second part, hence show that 2 sine cube x is equals to this. Okay, we know that this whole thing is equals to sine of 3x is equals to this whole thing. Okay, that means the integration of this is going to give us this. Okay, let's start with this. No, wait, hold on. This is equivalent to this. Okay. Okay, let's start from here only. Sine 3x equals to 3 sine x minus 4 sine cube x. Okay, if I make sine cube x the subject from here, 4 sine cube x equals to 3 sine x minus sine of 3x. Okay, so if I want to make sine cube x the subject, 2 sine cube x. So here I have 4 sine cube x. So instead of 4, if I divide by 2, so I have to divide this side also by 2. So I will write 2 sine cube x equals to 3 upon 2 sine of x minus 1 upon 2 sine of 3x. Okay, so if I, instead of integrating this, I can integrate this now. So I have to integrate this now. 3 upon 2 sine, the integration of sine is cos, so minus 3 upon 2 cos of x minus sine of 3x is going to be 1 upon 2. Integration of sine is negative, so it's going to be positive cos of 3x divided by 3. Okay, so I have minus 3 upon 2 cos of x plus 1 upon 6 cos of 3x. I have to put the boundaries of pi by 3 and 0 onto this. Pi by 3 and 0. Okay. So it's minus 3 upon 2 cos of pi by 6 plus 1 upon 6 cos of 3 into pi by 3. Okay, minus is the first bracket, minus. Now I have to apply 0. Cos of 0 is 1, so it's going to be minus 3 upon 2 here plus 1 upon 6. Cos of 0 is once again 1, so let it be like this. Okay, we know cos of pi by 6. Cos of pi by 6 is root 3 upon 2 minus 3 upon 2 into root 3 upon 2 plus 1 upon 6. Cos of pi is negative 1 minus, okay, plus 3 upon 2 plus 3 upon 2 minus 1 upon 6. Okay, minus 3 root 3 upon 4 minus 1 upon 6 plus 3 upon 2 minus 1 upon 6. So they've given the answer in a fractional format. Okay, let me solve this now. This is minus 3 root 3 upon 4 plus 3 upon 2 minus 2 upon 6. Okay, so I'm solving it with the calculator now. Minus 3 root 3 upon 4 plus 1.5 minus 1 upon 3. Okay, just hold on. Okay, I made a mistake here. It was a pi by 3 and I have put pi by 6 here by mistake. Pi by 3. Okay, everything else is the same, so I just have to change this number. So minus 3 upon 2 times cos of pi by 3. Okay, so this is minus 3 upon 4. Minus 3 upon 4. Okay, minus. Okay. Okay, it's coming out as 5 upon 12 now if I calculate it. 5 upon 12, exactly. Okay, moving on to question number 8 first. 8 is almost similar to the 7th one. I'm doing the 10th one then. This is the last question which we are doing. Show that sec square x plus sec x tan x is equals to this. Okay. Okay. Sec square x is the same as 1 upon cos square x plus sec x is 1 upon cos sec and tan x is sin x upon cos x. Okay, 1 upon cos square x plus sin x upon cos square x. If I take out the LCM, it will become 1 plus sin x upon cos square x. Okay, if I take cos square x is 1 minus sin x, 1 minus sin square x. Okay, and if I use the difference of two square formula, it will become 1 minus sin x, because here it's 1 minus sin square x. A square minus b square is a minus b and a plus b. This and this will cancel out. You're left with 1 upon 1 minus sin x. Proved. Okay, show that y equals to sec x, then dy by dx equals to sec x tan x. Okay, I think this we have already proved, but you can do it again. Okay, if y is equals to sec x. Okay, y equals to 1 upon cos x. Okay, u is equals to 1, u dash is equals to 0, v equals to cos x, v dash is equals to differentiation of cos x is negative sin x. Okay, so dy by dx is v u dash minus u v dash upon v square. This is sin x upon cos square x. So sin x upon cos x into 1 upon cos x, which is tan x into sec x. This is what we had to prove for the b part. Okay, hence show that 4 upon 1 minus sin of 2x is equals to this. Okay, I know that this is equivalent to this. So firstly I'm going to write, I'm taking help from here. Or I am taking the whole question down so that I can take help from both the parts together. Okay, 1 upon 1 minus sine x is equals to sec square x plus sec x tan x. Okay, so if I multiply it by 4 on this side. Okay, if you notice, if I multiply this by 4, because I want 4 here, so if I multiply it by 4 here, I have to multiply this whole thing by 4. That means 4 upon 1 minus sine x is equals to 4 sec square x plus 4 sec x. Now since I don't want sine of x, I want sine of 2x. If I'm multiplying this angle by 2, I have to multiply these two angles also by 2. That means, okay, so 4 upon 1 minus sine of 2x equals to 4 sec square 2x plus 4 sec of 2x. Now since we know that this is equivalent to this, we can integrate this instead of integrating this. Okay, so we have to integrate 4 sec square 2x plus 4 sec of 2x dot dx. And we have to apply the boundaries of pi by 6 and 0. Okay, so once we integrate, we know that the integration of sec square x is tan x. So it will be 4 tan of 2x divided by 2 plus 4 sec of 2x. Sec of 2x is the same as, okay, before I start with the integration, let me simplify sec of 2x first. 4 sec square 2x plus 4 upon cos of 2x dot dx. Okay, pi by 6 and 0 here. Let's start with the integration process, but before that, I'm writing something on this side. I know cos of 2x okay, if I take help from here, y sec of x dy by dx is going to be this. Shh. Okay, if y sec x dy by dx equals to that means if you're going to integrate this, you will get this. Okay. Okay, I made a mistake here, which I found very it was I forgot to write 10x here. That was the mistake. 10x here. Okay, let's do it from here, from the start. Let's start. Okay, that means now we have to integrate 4 sec square 2x plus 4 sec of 2x tan of 2x. And we know from here that differentiation of, I'm just using it here. I'm just copying this part. Okay. If the differentiation of this is this, that means the integration of sec x tan x is going to be dot dx is going to be sec x, and we have to integrate sec of 2x cos of 2x, sec of 2x tan of 2x. The integration is going to be the integration is going to be sec of 2x divided by 2. Okay, so and since we don't have to integrate sec 2x tan 2x, we have to multiply it by 4 as well. So if I multiply this side by 4, I have to multiply this side also by 4. So the integration of sec 2x tan 2x is going to be 2 sec 2x, which I can copy. Okay, now let's do it here. So we know the integration of sec squared 2x is going to be tan of 2x divided by 2 plus 4 sec x 2x. I'm copying it from there. It becomes 2 sec 2x. Okay. This is the result of integration. Now I have to apply the boundaries pi by 6 and 0 onto this. When I simplify, I'm getting a 2. So 2 tan 2x plus 2 sec 2x. Boundaries are pi by 6 and 0. 2 tan 2 pi by 6 plus 2 sec 2 pi by 6 minus 2 tan of 0. Tan of 0 is 0 only, plus 2 sec of 0. Okay. Tan of pi by 3 is root 3, so 2 root 3 plus 2 sec of pi by 3. Cos of pi by 3 is half. Okay, so it's going to be 2 into 2 then. Sec of pi by 3 is going to be 2 then. Minus tan of 0 is 0 and sec cos of 0 is 1. Okay, so sec of 0 is also going to be 1. So minus 2. Okay, 2 root 3 plus 4 minus 2, 2 root 3 plus 2. If you take out 2 as common, you'll be left with root 3 plus 1, which they have given it to you. Okay. Thanks a lot for watching the video. Hope you've learned something.